Hello again, welcome back to Topic 11, Kinetics, Energy, and Equilibrium. This is Section 11.2, Variables that Affect Reaction Rates, and our aim for today is to describe the factors that affect the rate of a chemical reaction. So, reaction rates. There are several things that affect how quickly a reaction will occur. These factors change the number of effective collisions that occur between particles. So in order to have an effective collision, we need the proper orientation and enough energy, but there are things that can help speed up a reaction or to help slow it down. The more effective collisions that occur, the faster the rate of the reaction. You make more products. The more ineffective collisions that occur, the slower the rate of reaction, and you will not make as many products. So the nature of the reactants. Reactions need to break bonds in order for the reactant particles to form new bonds for your products. So you need to break the bonds in your reactants and form bonds in your products. So which type of bond would be faster to break, an ionic bond or a covalent bond, and why? Covalent bonds are often slower than ionic bonds to break. Covalent reactants are nonpolar, while ionic are polar, and it takes more time to break your covalent bonds. They have more bonds between them that need to be broken, so it takes more energy to break additional bonds. Ionic reactants have less bonds that need to be broken, so if you have less bonds to break, this takes less energy. The more energy required, the slower the reaction, and the less energy it takes, the faster the reaction. So concentration, we talk about molarity and concentration. Will more or less reactants increase the rate of a reaction? And why? So if you have higher concentration levels, will that increase the chance of reactions occurring or decrease it? So you will increase your rate of reaction if you increase the concentration of one or more of those reactants. If you add more particles, it gives you a higher chance of a collision between particles. So that will increase your rate. If you decrease the concentration, you decrease the amount of particles that are able to collide. So then you decrease the rate. Surface area. If you have something that is in a whole particle, like a sugar cube, a whole sugar cube, or if you crush the sugar cube, which one will react faster? Okay, you increase surface area when you expose more of the reactant to the environment. So a squished up, smashed sugar cube will have more surface area exposed than a whole sugar cube. Which one will react faster? Okay, surface area, when it's increased, increases the rate of reaction. So if you try to dissolve a whole sugar cube and compare that to the rate that it takes to dissolve a crushed sugar cube, clearly the crushed sugar cube will dissolve faster because more of the surface area of that sugar is touching the liquid that you're dissolving it in. So it'll take less time in order to dissolve it. So it increases the rate. So again, an example, a finely ground powder reacts faster than a whole lump of powder. Pressure. If you change pressure, will this affect all of your substances' reactions? It has very little effect on solids and liquids. Okay, so pressure does not really change the rate of reaction for solids and liquids. It does have a big effect on gases, and we've been talking about this in relation to soda. Applying a lot of pressure on gases to push them into your carbonation to make soda. Pressure affects your gases. How does a change in pressure affect the rate of reaction for gases? So when you increase the pressure of a gas on a gas, it increases the concentration of the particles. So if you're able to put more pressure, you're able to push more of that gas into the solution. And this increases your concentration, which then increases the rate of reaction. Presence of a catalyst. So this is the first time we're talking about a catalyst. So what is a catalyst? Catalysts increase the rate of reaction. So it's something that you add in that increases how fast that reaction occurs. It provides a different and easier pathway for the reaction to occur. So it takes part in the reaction in that it enhances the reaction occurring, it increases the amount of time, the length of It decreases the length of time it takes, but it increases the rate of the reaction, but it is left behind. It does not actually react within that substance, so you still have the catalyst remaining at the end. So you start with a catalyst and you end with that same catalyst still there, so it doesn't get involved in the actual reaction. Temperature. How does temperature affect reaction rates? So if you increase the temperature, typically you increase the speed of those molecules. If the molecules are able to speed up, are you going to have more collisions or less collisions? When you increase the speed of the particles, you increase the chance of them colliding and thus forming products. So increasing temperature will increase the rate of reaction. The faster the particles are moving, the more energy they have. This also helps with your reaction, since we need enough energy in order to create an effective collision. So you're more likely to form products. So here are some things for us to write down. The factors that we have here are nature of reactant, concentration, pressure, temperature, surface area, and catalysts. And this is some information on how they affect the rate of reaction. So the nature of the reactant, whether it's ionic or covalent, okay? Ionic more than covalent. Oh, this should be an A here. That's a spelling mistake. What increases the rate of reaction? Ionic. If it's ionic, that is more going to affect an increase in the rate. Concentration, an increase in concentration will increase the rate of the reaction. If you increase pressure for a gas, that will increase the rate of reaction. If you increase temperature, it increases the rate of the reaction. If you increase surface area, it increases the rate of the reaction. And if you add a catalyst, that will also increase the rate of the reaction. Regents question time. In a chemical reaction, as concentrations of the reactant particles increase, the rate of reaction generally. So if we increase the concentration, we are adding more of the particles into the reactant side. If you have more particles bouncing around, you have more of a chance of collisions. So this will increase your rate of reaction. Which conditions will increase the rate of a chemical reaction? Decreased temperature. If we decrease temperature, we slow the molecules down. So that will not increase the rate and chance of them colliding into each other. So let's cross out 1 and 2. Decreasing temperature will not speed up our reaction. Increasing temperature will speed up our reaction by increasing the chance of collisions. And now if we decrease concentration or increase concentration of the reactants, which is more likely to create an increase in the rate of reaction, that of course would be increase in concentration. Increase in concentration means you've added more particles. That makes it more likely to collide. And that concludes part 11.2. See you next time.